Welcome to Microlecture 46. This is the first of our alkene addition reactions, the addition of HX to a carbon-carbon double bond. So the overall reaction here is going to be that of a carbon-carbon double bond reacting with HX. H will add to one of the two carbons and X will add to the other. So we're going to break the pi bond and we're going to make, in this case, an alkyl halide. X is usually chlorine, bromine, or iodine. So we're going to want to be able to write out a curved arrow mechanism, and of course we're going to want to predict the proper regio and stereochemical outcome. So regiochemistry is all about which side of the molecule reacts. So which atom is X going to add to, and likewise which atom is H going to add. And then the stereochemical consequences have to do with our dash wedge depiction and how we predict any stereo centers that form. Ultimately, is our product going to be chiral or achiral? So to do an example that might have some regiochemical and stereochemical consequences, let's take this alkene and react HCl. What's going to happen in this reaction is that we are going to expect two possible products, and they're going to look like this. And we would expect either of those to form equally, so this is a racemic mixture or a racemate. And therefore our product is achiral. So to understand why those products formed, we would have to be able to draw out a curved arrow mechanism. So the first thing that's going to happen in this mechanism is the double bond is the nucleophile. It's going to attack the proton of HCl, kicking out chloride. And the first intermediate here, or the intermediate rather, is going to place a positive charge. Carbocation forms on the more substituted of the two carbon-carbon of the two carbons in the carbon-carbon double bond. That is our intermediate. Chloride can then come in and attack at that carbocation site, and there's 50-50 chance of that chlorine attacking from the top and bottom face. So we'll say top and bottom, and there's equal likelihood of that. Okay, so that's why the two possible products will form. So what you're noticing is that H adds to the less substituted carbon of the carbon-carbon double bond, and X, in this case Cl, adds to the more substituted. So there's a complementary reaction that we can run if we wanted the reverse regiochemistry. So this is HX addition to alkenes with peroxides present. You're going to recognize that there's an oxygen-oxygen single bond here, and that's what makes this a peroxide, is that oxygen-oxygen single bond. So there's no mechanism required for this reaction. It's more of a set of reagents that you would want to recognize so that you could achieve the desired regiochemical consequence. So if we had the same alkene that we had before, but our reagent set was HCl in the presence of something like this, we would recognize the peroxide is present, and we would predict that H is going to add to the more substituted and chlorine to the less substituted. We do still expect a mixture of stereoisomers, so all possibilities would be possible. So we would expect this chlorine to form from the top or the bottom approach with equal likelihood. We would also expect the other possible products from having the methyl group be on either face as well. So there are 2 stereocenters in this product, and so therefore there's 2 to the 2 equals 4 possible stereoisomers. Okay, so our R, SS, RS, and SR would all be equally likely with this chemistry. So for this one, just be able to predict the product, and also be able to provide the reagent. It will be given in a list of reagents. So you would just have to be able to pick that reagent set out.